Hi! In today's video, we'll be discussing Newton's first law of motion, also known as the law of inertia. We'll be discussing how forces cause changes in the motion of different objects. So from our last video, there are two big concept takeaways that you'll need in order to understand Newton's first law. The first was the concept of net force, which we know is the sum or the addition of all forces acting on an object. We know in order to find the net force, you need to sum all of the forces on the object to determine the total or the net force acting. Using net force, we also discussed the difference between balanced and unbalanced forces, with the idea that balanced forces are when the net force of all forces acting is equal to 0. Whereas unbalanced forces, the net force or the sum of all forces is not equal to 0. Using this information in Newton's first law, we will be able to explain how and why objects experience changes in their motion or why they don't experience changes in their motion. We'll be able to return to these different examples. So the rock sitting on the floor, why does that rock just continue sitting on the ground? Versus the golf ball, why does that ball begin to fly through the air and eventually come back down and stop moving again? Today, we'll be able to use Newton's first law to answer each of those questions. So Newton's first law, also known as the law of inertia, tells us that any object in motion will stay in motion and any object at rest will stay at rest until they are acted on by an unbalanced force. This means that objects that are at rest or not moving will stay at rest or will continue not to move until they're acted on by an unbalanced force. It also means that objects that are in motion or moving will stay in motion in the same direction and at the same velocity until they are acted on by an unbalanced force. The reason that this is true is because of inertia. All mass in the universe has a characteristic called inertia, which is the tendency, or the habit, you could say, of resisting changes in motion. To put this simply, it means that any object with mass wants to, or is going to try to, maintain its current state of motion. That means that it is going to require a force in order to change that object's state of motion or to cause acceleration, as we would put it. More massive objects, so objects with greater mass, have more inertia. This means that in order to cause an acceleration of a greater mass object, it will require more force. You can think of trying to push a small toy car and then trying to push a whole truck. You know that it is going to require much more force in order to overcome the inertia of the truck because it is so much more massive, as opposed to the small car, which has barely any mass and hence very little inertia. So let's compare now what we know of Newton's first law to our examples. So using Newton's first law, why is it that this rock sitting on the ground will just continue to sit on the ground? Now the at-rest example is pretty straightforward. So we know, according to Newton's first law, that as long as forces are balanced, or the object is not being acted on by an unbalanced force, an object that is at rest will stay at rest. So if we think of our rock sitting on the ground, the forces acting on that rock are balanced. There's a gravitational force acting downward towards the center of the earth, and a normal force acting exactly opposite of that force in the upward direction. We also know that these forces are equal in magnitude. That means that if we sum those forces, the net force on this rock will be equal to 0. For that reason, according to Newton's first law, this rock will remain at rest if and until it is acted on by an unbalanced force. Now let's think of the golf ball sitting on the tee getting ready to be hit. In that case, the golf ball is also experiencing balanced forces, the gravitational force pulling down and the normal force acting back up on the tee. That is until it is acted on by the unbalanced force of the golf club swinging and applying a strong applied force to the ball. Now that the ball is acted on by an unbalanced force, This will cause a change in its motion or an acceleration, causing the ball to start flying through the air. Now, let's think about this golf ball that is in motion. According to Newton's first law, that golf ball should stay in motion forever until it's acted on by an unbalanced force. We know that that's not going to happen, and we know that eventually, very soon after, that ball is going to fall back to the ground, roll for a little while, and stop moving. That is because the forces acting on the golf ball as it flies through the air are unbalanced. There's a gravitational force pulling it towards the ground and no force counteracting it. There's also air resistance counteracting its motion in the horizontal direction. Very, very unbalanced forces. That means that shortly after it starts flying through the air, that ball will begin to decelerate or accelerate in the negative direction, slow down, and eventually fall to the ground, roll for a little while, and come to rest. Now that we know Newton's first law and how it applies to some common examples, let's break down all of the possibilities of forces that an object can experience and the outcome to the object's motion using Newton's first law. So first we'll talk about an object at rest. This is really the more straightforward of the two examples, so we'll start there. So first we know that an object can experience a balanced force. So according to Newton's first law, if an object is experiencing a balanced force, it will cause no change in the object's motion or no acceleration. That means that an object at rest that's experienced balanced forces will remain at rest. Now let's look at an object at rest that's experiencing an unbalanced force. According to Newton's law, we know that when acted on by an unbalanced force, acceleration will be caused, or a change in the object's motion will be induced. If an object is at rest and it begins to accelerate, we know that that object will no longer be at rest, but instead will be in motion. Now, let's use Newton's first law to break down the possible changes in motion for an object that's already in motion. So of course we know that an object in motion can be experiencing balanced forces, or a net force equal to 0. In this case, according to Newton's first law, we know that this object would experience no acceleration. So what does this mean for an object in motion? This is the part that you really want to think about. So if an object is in motion and it's not accelerating, that means that its velocity is staying the same. This means that that object that was already in motion will remain in motion at the same velocity, meaning at the same speed and in the same direction. An object that's already in motion can also be acted on by an unbalanced force. According to Newton's first law, we know this means that object will experience changes in its motion or will experience acceleration. So for an object in motion, this means that this object will experience a change in velocity. That can either be an increase in speed or a decrease in speed, and or a change in direction. So if you know this breakdown of all of the potential outcomes for an object either at rest or in motion, you will be able to use Newton's first law to analyze the changes in motion that occur to any object experiencing any set of forces.